have the pleasure to introduce Sébastien Marot here in the Paris-Est EPFL, and also Jean-Baptiste Fressoz remotely from Paris. They will have a discussion about this very notion of transition from an historian perspective, from this about this pervasive watchword. Sébastien Marot is visiting professor at EPFL of environmental history and theory, and professor at the Ensavt Architecture de la Ville et du Territoire Marne-la-Vallée, Paris-Est. He's the author of many publications focusing on the genealogy of architecture theory, contemporary practices, and urban design. We can mention here at least L'art de la mémoire, le territoire et l'architecture, the art of memory, region, and architecture. In 2019, he curated the exhibition presented within the framework of the Triennale of Lisbon, taking the countryside architecture, agriculture, and architecture, sorry, which was also presented in this school, and those content is now online. In respect, he developed a reinterpretation of 4 scenarios from which we will question the very notion of the transition tonight. And just to briefly introduce Jean-Baptiste Fressoz, he's an historian of sciences, technology, and the environment at the CNRS. He's the author of L'Apocalypse joyeuse, L'événement anthropocène, and Les révoltes du ciel, and is now working in a new history of technology. And I give you the floor, you to Sébastien.
Okay, thank you, Valentin. When you suggested that I intervene in this Master of Advanced Studies and think of someone with whom it would be interesting to have a conversation, I immediately thought of Jean-Baptiste for many reasons. I'm going to show you, he's a historian of the environment in France, one of the most important, and someone who's written several books, which I'm going to show. And but Jean-Baptiste, you will tell me if sometime, sorry, just a second, if sometime. So he wrote many essays and articles. I'm just going to show a few books which he either edited as an editor, a re-edition of a
Je vous entends plus. Sébastien, I can't hear you.
Tu m'entends pas là?
Yes, no, it's okay. It's back. Sorry.
So here is L'Apocalypse joyeuse, a history of technological risk, published in 2012, I think. A quite important book in France that he published together with wrote together with Christophe Bonneuil, another environmental historian. The shock of the Anthropocene, which is this one available in English in different editions, and a little book to mention also his participation to the book Introduction to Environmental History with other colleagues here, and more recently Les révoltes du ciel, a history of climate change from the 15th to the 20th century. I would say that one of Jean-Baptiste's contribution to the debates today is to put our environmental concerns and preoccupations, which we think are with us, since, let's say, the 60s or 70s, to show very convincingly that truly those problems were in the mind of people already in the 15th century. he shows very well in Les Révoltes du Ciel how, for instance, the colonization, the discovery, as we say, of the New World went or started many very deep questioning of what we were or what people were doing to the climate, at least the colonizers, for instance. But not only in the colonies, also, of course, in Europe and elsewhere. So basically, Jean-Baptiste is showing that what the concerns which we think are ours, just since that period, since for 50 years, were really concerns that were there before the Industrial Revolution, and that if we seem to rediscover them, but in fact we, or people, inhibited them, or there was a disinhibition there. And we met just a few times with Jean-Baptiste, but I remember the last time we met, he told me that he was now questioning, that was one of his projects, was to question the idea of transition, of energy transition, which is a kind of catchword nowadays, and to try to do a kind of critical genealogy of the use of that term. And since I saw that in this master the term transition is put forward, I thought it would be good to have a conversation with him on this particular subject, if only to be a little less naive when we use it here. I prepared just 2 or 3 slides, but maybe I'll show them later and just leave the ground now to Jean-Baptiste.
Okay, thank you, Sébastien. Thank you, Valentin, for this invitation. So I'm going to talk about a work in project, which is indeed a kind of new, if it doesn't sound too bombastic, history of energy. Today, I would like to emphasize the fact that the idea of transition, of energy transition, which is completely overwhelming now, which is everywhere. For a very long time, it was extremely marginal. It was a fringe notion. It was not at all the vocabulary of the experts, if be they engineers, geologists, economists, foresters, oil geologists, all those people that have written on the history of energy and thought on the future of energy. They never used the word transition, and they were not convinced at all that there would be a transition. I mean, it would be quite meaningless actually in their mind. Nevertheless, when you look at the historiography, the way history of energy is written, it is completely framed in a transition narrative. If you take the major books that have been published even recently, I mean, they all have this transition narrative from organic energy to coal and then to oil. I mean, this idea or this kind of ground fresco of energy transitions is really the dominant genre in the way we write the history of energy. The other point of surprise is that if you just look at what economic ecologists are doing on the flows of materials, well, you have a very different story. You have a story of pure accumulation. If you take all materials consumed by humanity, the quantity of materials has been multiplied by a factor 9 between 1900 and 2000. There is a new great acceleration in the consumption of materials starting from the year 2000, which takes place after, of course, the most famous great acceleration, which is the great acceleration of the 1950s. We have never consumed as much oil as now, never consumed as much coal as now. So how come that this idea of transition is so dominant? So what I would like to emphasize is that the history of energy is a history of energy additions and energy symbiosis. Energy additions, it's quite easy to show. I mean, of course, hydraulic energy is not decreasing in the 19th century. It is only increasing and it's getting more and more industrialized. If you take windmills, wind power is not a traditional energy in the 19th century. It's a very modern energy. You've got millions of windmills which are industrially produced in the US, which are powering millions of pumps in the Midwest in particular, which allows this fantastic new history to open, which is the cultivation of the vast plains of the Midwest. Okay, so a really extremely important transformation of the US is powered by wind. In the same way, when you think just a little bit, you see that human muscular energy is also being modernized in the 19th century. It's not a traditional energy. You've got plenty of small inventions, technologies which are not studied by historians, which completely transform the way you use the human muscle. The human muscle is modernized by ball bearing, ball bearing technologies, by all sorts of rubber technologies, just have a flat cemented floor and a rubber wheel completely transform the kind of force you can exert with the human body. One example would be, for instance, the narrow gauge railway, the Decauville railway. Narrow gauge railway, you've got thousands of kilometers of narrow gauge railway tracks which are used by humans or which are powered by humans or by horses, which are laid in the late 19th century. So we're not talking about small marginal technologies. We are talking about modern technology that really transform the history of energy. I will skip that. Nevertheless, when you have, serious quantitative work, or would-be serious quantitative work on the history of energy, you've got this kind of graphs. I will enter in some details on this graph because I think it's a very important graph. I mean, this is data which has been collected by an historian called Paul Ward and is behind most of the narrative, the recent narratives on the Industrial Revolution. If you read Václav Smil, if you read Anthony Wrigley and other historians, actually they are using this graph. And this graph, it is the energy of using Great Britain in between the 16th and the 19th centuries. It is expressed in energy terms, in megajoules. And here you've got the energy in Italy in the mid-19th century. There are many strange things in this graph, but the one aspect I would like to focus on is firewood. When you look at firewood, you see this is the dark gray here. It decreases to 0 in the 19th century. So it seems that Britain would not use any firewood to power its economy in the mid-19th century. But now let's look what happens in the mines. In the late 19th, early 20th century, you've got thousands of kilometers of coal mines, of galleries in the British coal mines. And these coal mines are using millions of tons of wood just to support the roofs of the galleries. When I'm saying millions, it's 4.5 million, if you take an exact number. 4.5 million tons of wood per year are used to support the roofs of mine galleries. 4.5 million tons, it's quite an abstract figure, but just to give you a point of comparison, in the mid-18th century, in Britain, the British people would burn only 3.5 million tons of wood for energy, to warm themselves, to produce material goods, and so on and so forth. So just the mines, the coal mines, are using more wood than Britain would burn in the mid-18th century. So when you tell the story of a energy transition in Britain in the 19th century, you're telling a very peculiar story, a very strange story. And of course, it's not just Britain, it's all the coal mines in the world are using enormous quantities of wood. I mean, Russia in the mid-1960s, it's nearly 25 million of cubic meters of wood that are used in the mines. This is more than what the French forest produced in the late 19th century. So we are talking about enormous quantities just to support the coal. But this argument goes for all the great technological system of the Industrial Revolution. It goes for railroads, especially in the US, and wood consumption explodes because even if you don't burn wood, you use wood for many other things. I mean, this is the graph of the consumption of wood in Britain. In the 19th century, it is multiplied by 6 and by 3 if you take per capita consumption. So you got a symbiosis between wood and coal, not a transition. It's not the two materials are not in opposition. They have a completely symbiotic relationship. And this example goes for other materials. If you take an example, oil, petroleum, and wood, you got exactly the same relationship. This is quite anecdotal, but I like this example. This is a picture of the largest barrel manufacturer in the US and in the world, actually, at the beginning of the 19th century. And this wooden barrel manufacturer is mechanized, industrialized, and it belongs to Standard Oil. Because even if you have pipelines, tankers, even with all these technologies, if just a small part of oil is stored in wooden barrels, that necessitates a huge amount of wooden barrels, much bigger than all the wooden barrels produced for the French wine, for instance. But of course, it's not the most important technology. I mean, what really matters is technologies such as the chainsaw, all sorts of forestry equipment which are diesel powered, and oil is also used to produce plastic, and plastic completely transformed your possibility to have forestry roads. You can have forestry roads on slopes in mountains, which was very difficult before this, what you call geotextiles, which is in fact plastic. I mean, these kind of examples, I could repeat them over and over. They're going to bore you. Or just give you another example. If you take an automobile in the 1920s, in automobiles, just to produce an automobile, you use more coal than what the automobile will burn in its lifetime. It's approximately 2.5 tons of coal, and it is more or less what the automobile will use in terms of oil in the 1930s. This is the picture of the famous Rouge factory of Ford in the 1930s, and you've got a huge stack of coal, and the power plant for the factory is the same size as the power plant which would fuel a city of 1 million inhabitants. So just to convince you, I mean, I'm trying to convince you that transition is probably not the best word to frame a history of energy. So my second point is, where does it come from? How come that energy transition is so dominant in our narrative? First of all, this is fairly recent. I mean, this is one of the early graphs representing the evolution of the energy mix of the world. And here you've got clearly a cumulative story. I mean, of course, coal decreases after 1929, but because of the economic crisis, and it's also because of electricity. Electricity allows you to get rid of the old steam engine, which are very, very, very inefficient, and thus you can economize a lot of coal. But this is the way you normally describe the evolution of energy. You use, for instance, logarithmic scales, which allows you to show you the relative stability of wood. Or I like this one very much. I mean, this is a futurology, a projection made by a promoter of solar energy. And you can see that the future which is envisioned is not at all a future of transition. All the sources of energy are growing. And the way the future is seen, basically it's a bigger present. It's not a very different present. It's a bigger present. And there is no important transition between energy sources. So where does it come from, this idea of energy transition? You can locate quite precisely, actually, where it emerges. It emerged from a very narrow group of people, which are both atomic scientists and very important atomic scientists, and neo-Malthusians, people that are obsessed with the idea that we're going to exhaust mineral resources, and especially oil and then coal. at that time, atomic energy is seen as the solution to the Malthusian dilemma. Because if you've got enough energy, you can increase the carrying capacity of the planet Earth. For instance, you can desalinate the water of the oceans, you can produce fertilizers, and you can irrigate vast tracts of arid lands and grow food for billions more people. So it is really this in this very specific group of intellectuals that the idea of energy transition emerged. The first to write the phrase energy transition, it is in a paper in 1967, and it is Harrison Brown. He worked at the Manhattan Project as a young chemist, and he was fascinated by the breeder reactor, and all this idea of energy transition is actually propaganda for the breeder reactor. Another important intellectual is Marion King Hubbert. Marion King Hubbert is, most of the time you just talk about the peak oil, but in fact, Marion King Hubbert was deeply involved with the Atomic Energy Commission. He was hired in 1955 because the Commission was trying to find a solution to get rid of nuclear residues of radioactive materials, especially liquid materials. And Marion King Hubbert is a petroleum engineer, and he was invited to participate because the Atomic Energy Commission hoped to just throw away the liquid residue in old oil wells. But actually, Marion King Hubbert was interesting for the Atomic Energy Commission for another reason. He was one of the early promoters of this idea that we're going to have the US are going to run out of oil quite quickly, not in a few centuries, but in a few decades. And he was fairly right about conventional oil, by the way. And he introduced this idea of peak oil, but the peak oil is a peak just because you compare it to the vast plateau, energetic plateau of the nuclear energy, and especially of the breeder reactor. So it is really, all this idea of peak oil is also part of a much broader propaganda in favor of the atomic energy, and especially of the breeder reactor. And all the reports of Marion King Hubbert on peak oil are used in official reports, official documentation to increase the finance of the Atomic Energy Commission by the Congress, for instance. A very important notion before the energy transition is the idea of energy crisis. And it is far more important in linguistic terms in the 1970s than energy transition. And it goes hand in hand. When you think about energy crisis, normally, in what historians have written, it is linked to the oil shock of 1973. But in fact, the notion comes earlier, and it's clearly an invention of the Atomic Energy Commission, of the nuclear lobby. And the main issue is electricity, it's not oil. It is because in New York, for instance, you had blackouts in the 1960s, and this was due to very specific economic reasons. I'm not going to enter into many details, but the Atomic Energy Commission tried to reframe this problem in electricity distribution as a neo-Malthusian problem. We're going to run out of coal. We are on the way to a catastrophic collapse of the US economy because of this exhaustion of fossil fuels. And this is a nice, I like quite a lot this advertisement for General Electric, which is an advertisement for nuclear power and for a fast breeder reactor. And this is put forward as the solution to the exhaustion of coal. So this idea of energy transition, which emerged in the late 1950s, early 1960s, in the realm of atomic scientists and neo-Malthusians and the Atomic Energy Commission, then becomes really a very common word, a key topic after 1973, which plays an important role because then everybody talks about energy transition. It's not just the nucleocrats, it's everywhere. And actually, this is perhaps the crux of the problem. The vocabulary, which was a very technophile vocabulary put forward by the nuclear scientists, became the language of environmentalists, for instance. Friends of the Earth and other major environmental organizations after 1973, they all produced energy transition scenarios. I mean, here you've got three different scenarios. I'm not going to enter into details, but the one by Amory Lovins is famous. It's the soft energy path, which create a huge stir in the energy debate in the US, because Amory Lovins explained that you could have renewable technologies completely satisfying all the energy needs of the US in 2025. So you've got the same vision of a very malleable world, just as which was the vision of the nuclear scientists, which now is infused in the discourse from the environmentalists. The key character to really popularize the idea of energy transition is the US President Jimmy Carter. In 1977, he made a great discourse on energy transition, which is really a kind of history lesson. It's in front of the TV, in front of the national television in the US, and he says, in the past, the US has accomplished two transitions, one from wood to coal, the second from coal to oil, and now we have to accomplish a third transition. What he has in mind is actually more coal, because what he wants is national sovereignty, autonomy from the OPEC cartel. And to put forward this idea, he presents this very strange graph. I mean, it is very different from all the graphs that I have shown, which were cumulative. Here you've got a vision of transition, indeed, from fuel and then coal and then oil, a kind of very harmonious energy history based on three materials. This graph is taken up by a very fascinating character, an Italian nuclear scientist called Cesare Marchetti. Cesare Marchetti, I really quite like this character because he's both the most technophile character of the story and at the same time the most interesting historian in my story. Cesare Marchetti is famous because he's the father of the hydrogen economy. He's the first one to put forward this idea that we have to produce hydrogen. Is a staunch promoter of nuclear energy. He's a nuclear physicist. He worked for Euratom, the European agency specialized on atomic energy. But he has a clear vision that if you limit nuclear energy to the production of electricity, then nuclear energy is not very important because electricity is just one small part of the energy mix. So you have to conquer liquid fuels. And to do that, you have to use nuclear energy to produce hydrogen. How you do that? You build enormous nuclear plants in the middle of the oceans. So you don't have so many neighbors complaining about nuclear plants. And then you produce hydrogen from the water of the oceans and you ship this hydrogen using tankers. Okay, so we had this vision of really a nuclear hydrogen economy in the 1960s. But at the same time, he makes the effort to try to see how long it could take for this vision to become reality. He goes to YASA. YASA is a International Institute for Advanced System Analysis. It is a new institute founded in 1972. It's near Vienna in Austria. And in this international organization, you've got a project on energy transition. It's very much dominated by nuclear scientists. And what Marchetti does, he starts compiling many data on the evolution of energy mix, and that's why he made this graph. And he shows that, he tries to show that the diffusion of energy follow a logistic curve, not the famous logistic curve, the S curve. It works very well for technologies, and it was used massively to model the diffusion of technologies. If you take mobile phones, they have diffused according to a logistic law. If you use, all sorts of technologies diffuse according to logistic law. So he takes this method and he applies it to sources of energy. And he has this very deterministic vision of the substitution of energies. which is based on kind of historical laws. You infer from the past the logistic equation of the diffusion of energy, which allows you to predict the future. And it reaches a quite pessimistic conclusion. Basically, it will take much longer than what everyone thought to get out of fossil fuels. He's very critical of the way models were used. I mean, at IIASA, they used the methodology which was developed by the Club of Rome, by Meadows, the Meadows at the Club of Rome. And he's very critical of all these numerical models. Because you can feed them with different parameters, and they produce as many simulations as you enter parameters. And he has a very powerful critique of these models. He says, basically, it gives you the illusion of governability. It gives to the government the illusion that they can really manage such an enormous thing as the global energy system. This enormous ensemble of machines, people, needs, uses, resources, prices, economies, this enormous thing, which is the global energy system, according to him, you cannot change it, actually. It evolves according to intrinsic laws of evolution. It's a very deterministic, it's clearly too deterministic, and Marchetti was wrong in many respects in his forecasting. But at the same time, he was critical of this method, which is still with us. I mean, when you take the models of the IPCC, of the group 3 of the IPCC, they use the same kind of modeling, and it makes sense because IIASA was important at the beginning of the IPCC, at the group 3, the one which deals not with the physics of climate change, but on the dynamics of energy systems. I mean, I had the chance to interview him. He's 94 years old now, and he told me this is all these models, you know, the fact that the CO2 could, you have to, you know, many different trajectories. They look like a spaghetti dish, a plat spaghetti. So he's very critical of all this. And for him, history is really what matters if you want to do proper energy forecasting. I will conclude on what happened in the files of the oil industry. The strange thing is, after Marchetti's work and after the IIASA report, which takes part of the Marchetti's work in 1980, the idea, which is quite dominant, is that energy transition has taken place in the past, based on Marchetti's figure, and it takes 50 years to have an energy transition. It's really strange because Marchetti explained that it takes much more than that. It takes 100 years for oil to become important. For instance, between 1860 to 1960, oil was next to nothing in 1860. It was important, 50% of the energy mix in late 1960. It took 100 years. But nevertheless, in the international forum where you talk about climate change, it's quite natural that you can have an energy transition in 50 years. Even climatologists use this figure. James Hansen, for instance, invited this guy, Edward Davids, who is the head of research of Exxon. James Hansen is a famous climatologist, kind of hero of climate change. But in 1982, he invites the leader of Exxon to give a great speech in front of scientists. And Edward David explained that, yeah, there is a problem with climate change. Of course, CO2 emissions is warming the planet, but it's not the interesting point. The interesting issue is what will happen first, climate change or energy transition. And both are described as natural phenomena. Just as certain as climate change, there is an energy transition, he's telling us. And the strange thing is, you know, James Hansen is actually thanking him for this great conference, and it becomes a normalized idea that you can have an energy transition in 50 years. In fact, Edward David had a perfect comprehension that it would take much more than 50 years to get out of fossil fuels. And when he was explaining to climate scientists that there was climate transition at play in the US, he was actually investing in coal to fuels technologies. I mean, the liquefaction of coal to produce more liquid fuels. He was investing in coal mines. He knew that coal was getting more and more important in the US. And it is, of course, at that time that coal is going to reach its apex in the US. It's in 2008. It's not, of course, in the 19th century. It's in 2008. And you had other modelers, especially David Rose, who IT, who explained that why it was very complicated to produce any energy transition. I mean, he gives very simple reasons. Basically, the later you start the transition, it has to go very fast. So you have to produce an enormous amount of energy equipment in a limited period of time. And he takes the example that if you start the transition in the US in 2010, you have to put more than 50 times what General Electric and all other large electric manufacturer in the US, 50 times that in the next 20 years. And he says capitalism will never accept such a kind of short-term transformation of the material basis of the energy production, because all these investments in solar panels or atomic plants doesn't matter. I mean, you have to invest massively in 20 years and then stop, because when the transition is done, you don't have to do it again. Okay, and that is completely contradictory to the logic of capitalism. So, and what David knew about this research, and there are other models showing how complicated it was going to be. I will conclude by saying that the sad thing is that what we have lived since 1975 is actually even worse than what the most pessimistic were envisioning. Marchetti was among the pessimists. And for him, it would take perhaps 100 years, but he would expect nuclear to be much more important than it is now, or renewables. He didn't care in the end if it were renewables or nuclear. And in fact, we're exactly at the same level of dependence on fossil fuels as we were as in 1978, more or less 80%. Okay, I stop here. I hope it was helpful.
Yeah, Jean-Baptiste, thank you for this very demoralizing view of the concept of transition, its use, etc. But what lessons do you draw from this little historical survey for the meaning of transition today? Because there are many users that are done of this term. Some, of course, may be following the true and historical origin of it, want to replace current energies by other energies that would supply what they supposedly won't provide in the future. But many, I think of, for instance, cities in transition of Rob Hopkins, etc., are just talking of transition, saying we have to prepare for a world with less energy.
Okay.
Right? So there are many different meanings.
Sure.
So what kind of meaning would you say, if you would say any?
The point is not saying that a transition is radically impossible, that it will never be done, because I'm not, I don't want to be a futurologist. I've seen enough of bad futurologists to try to become one. The point is to remind us that there has never been a transition in the past. We have never experienced such a thing. What we have done is completely unprecedented. Okay. Whereas, and it is especially true when transition was first used, the discourse of transition was based on an historical narrative. The idea was that in the past there were transitions made by innovation and capitalism, and this system is great to innovate, so we have to continue on this in this regime. I mean, it was really the meaning of transition for most of its history. So behind this idea of transition, there is the idea that you can change the material or energy basis of society without changing so much the society. So I think it's a very, very bad word. And it's quite sad that the environmentalists have taken up the word. I think it's not their word at the beginning. They didn't care that much. In the 1970s, they were just against nuclear, basically. That was, it was their identity. The US, the friend of the earth, was against the nuclear energy. And after the oil shock, oh no, they became in favor of energy transition, which is, of course, very important for the normalization of the environmentalist movement. And many environmentalists become advisor to the Jimmy Carter's administration, for instance. So we have been, I mean, I think the main point is to understand that we have a wrong vision of the material constitution of our society and its history. We think that there are big shifts, big transformation, because we have a vision which is obsessed with technologies. And it is true that technology evolved and sometimes substitutes, even if it's quite, actually, it's less frequent than what we think. But when you look at materials, this vision is completely wrong. You have to see the material world as a complete matrix of symbiotic relationship between different materials. And this matrix is only expanding. It is extremely rigid. You have very little transformation in the matrix. So I think that's what I want to emphasize. So there is no positive lesson, I think, except that indeed you have to decrease material consumption. It's the first thing to do, of course. But once again, imagining that you can have the same kind of cities with electric vehicles instead of petroleum engines, and then you reduce the CO2 emissions, it's just plainly wrong. I mean, if you use renewable energy, which are great to power electric vehicles, automobiles, then you need cement because you have to maintain the roads. You have urban expansion, so you need more cement to produce new buildings. You have more iron to produce the. Of course, you know that, all of you know that better than me, but architects and urbanists are, of course, crucial players here.
So in other words, if I sum up what I understood from what you said, is that transition, in fact, names an idea or an ensemble of policies that there to counter a deeper realization of the situation, are a kind of anti-revolution or and that there, So there is nothing to say in this.
There's very little to say, I think, from this. It has such a loaded past. That I think it is more blinding us than helping us. I mean, I'm sorry to say that to if your master is entitled and I just want to emphasize that the father of all transition is the energy transition. You first have energy transitions, and then you have ecological transitions, urban transitions, agricultural transitions. There is one transition which comes earlier. It's demographic transition. And it is linked, I'm not going to make my speech again, but it is linked to this idea of neo-Malthusianism, which is very important in the story.
Okay. Jean-Baptiste, I wanted to share with you two little things. If I can share my screen. Vous m'entendez? Yeah, I wanted to show to talk just briefly of a book. You want me to activate my mic?
Oh no, it's okay.
Okay. Which is a book by David Holmgren, you know, one of the co-founder of the permaculture movement, which in 2008 published this little book. Have you ever seen this book? Jean-Baptiste?
Heard of Holmgren, but to be honest, I haven't read the book. No,
Yeah, yeah. Because it was not really published widely at all, and I found it the cover is horrible, but the book is kind of interesting. It's a very simple exercise that he does there, you know, by imagining, say, basically. Some people think that the future will be a techno explosion, continued growth, etc. So he calls that techno explosion. And other people see the future as a techno stability that will be reached at some point, thanks to transition things. There is a scenario which he calls, after Odum and others, energy descent. Progressively, and then of course the collapse, 4 different long-term futures. But then he comes to this little graph to summarize the situation today and what he calls midterm future. And he says so it's a caricature. It's a way of summarizing basically the situation. You see that the vertical arrow he calls global warming. It means basically global warming, also biodiversity collapse. It's the degradation of conditions of life on Earth, right? And it can be benign, below, or fast and furious on top. And at the same time, there is another problem, which he calls oil decline, but you could put also, I don't know, a metal decline. It's non-renewable resources and energy stocks declining, either slowly. So on the left, you still have power to act or to power, basically, or fast oil decline where you have less dense energy. And he crosses those two things and he says maybe each of the quadrants would be a kind of different scenario. On top left, he calls it brown tech. It's the conjunction of still a lot of energy, maybe even more, and very destructive global warming. And he calls that brown tech because he sees that scenario as that of command government, very dirigist economies, governed by the high tech, and the techno structure. The sea rises, you build enormous levees against the thing. You have power, you can do this. Just under that thing, a scenario that he called green tech, which is at the conjunction of slow oil and material decline, and still benign global warming. So basically, it's the best of those 4 scenarios on paper, which he calls green tech. People are going to transit, use the energy that they still have and the material that they still have to build a new, I don't know, infrastructure, solar panels everywhere, wind turbines, and other kinds of devices to prepare for a situation, where the degradation will accelerate, or maybe prevent this acceleration to come. But then you have a third scenario, which is exact reverse of the first, where you still have global warming, which is not terrible or accelerating too fast, and then energy descent, which is bad. And so here, it's basically the scenario that permaculturists dream of, you know, because it would produce, according to Holmgren, exactly the reverse that the mobilization of fossil energy did during the industrial era, that is to concentrate populations, you know, in, for instance, huge cities and things like that. You would have a kind of urban exodus in his view, because you have to care of the living energy where it is dispersed, etc. So earth stewards. And then the last, of course, which is the worst on paper, where you have both climate destructive global warming and fast material and energy depletion. And this he calls lifeboats. There is no world war, because you don't do world wars with without you know, a lot of energy, but it's a bit, maybe a bit of a Mad Max Matrix, I don't know, situation. But what he says is these scenarios are not exclusive of one another. First, because there are regions in the world which are in different situations. He believes that Australia, that still has a lot of coal, for instance, but is like badly confronted to the consequences of climate change in different guises, that it's going to brown tech. He wrote a text called Welcome to the Brown Tech, and he now more and more sees the brown tech as the scenario which is actually happening everywhere. And maybe it describes too well the situation by which he defines it. Still a lot of things to burn, and a destructive global warming, if we believe the GIEC. And then he says there are also even like puppets into, you know, New Zealand, for instance, in different situations as Australia, according to that. So you have different situations. I would like to know what a historian like you, deeply informed on the history of global warming and in the history of energy, thinks of such a little way of summing the different possibilities.
Well, if you precise the geography, I mean, if you specify the geography, just as you did, I think it can be helpful to indeed emphasize the fact that different people on Earth will have very, very different futures.
Yeah.
Futures. I mean, that's, I think, the crucial point of what you said. My feeling is that it tries to reconcile the issue of global warming with a far older issue, which is the exhaustion of energy, which has been an obsession since Jevons, at least, and even earlier, actually, which has always proven wrong. So that's why I would say I'm not sure it's so interesting to put oil in this graph.
Oil.
What I understand from all the reading that I have done on, in the 1970s, they were really preoccupied by the fact that oil was declining. It was really a serious issue. The experts were not very stressed by that.
The what, sorry?
They were not stressed. They were not so preoccupied by it. At the YASA or the American Academy of Science, they say, yeah, there is a problem because of conventional oil. But first of all, we've got still plenty of unconventional oil. We can transform coal into oil. And now, speaking in 2020, I could say that one of the worst, the nightmarish world would be a mix of coal and electric cars. You produce electricity with coal or with nuclear actually, and you don't need so much oil as before. So I would say that if you take off the other issue is oil is very often in this kind of collapsology discourse. It's not collapsology, I understood, but it's very often connected to the transformation of agriculture. But in fact, agriculture consumes 1.5–2% of oil that we use. So even if oil becomes much, much dearer, much more expensive, other sectors will be deprived of oil, transportation, and then there will still be oil for agriculture, because this is, of course, more important than moving people around, or aviation, for instance, that will, of course, suffer before. So I think there are several issues about that. Naomi Klein wrote this book, This Changes Everything. And I think it must also change environmental thinking. Climate change changes everything, also the discourse on environment. And we have to be, a bit critical from what we inherited from the 1970s and this kind of futurology. On the other hand, if you say that the most probable is brown tech, I can only agree. It's exactly where we are heading to, indeed. It's the future that is being prepared. Basically, the oil companies are going to be gas companies more and more, but that just delayed the problem for a few decades, but it's not solving the problem. The thing is, most of the technologies that we are discussing, they're not really solving the issue, they're just delaying it. If you use electric car, it's not, you call that a zero emission car, but it's a half emission car. So it's just delaying the problem for 10, 20 years, perhaps, no, even less, actually, probably. So, that's the main issue is the production of materials. Mm-hmm. That's really what and that's why I think urbanists and architects are very important. We could decarbonize the electricity production. It's possible. It can be doable in perhaps not 30 years, but it can be done. But to decarbonize the production of cement, of fertilizers, also of iron, this is much more difficult. So it's really about the construction of the material world that we have to talk about. Yeah. And escape the narrowness of the discourse on energy and electricity.
So for instance, you think that all the alarms in the 70s on energy descent or now material descent are not going to, have proven false?
Well, they have proven false till now. I'm not sure about the future, but it's quite improbable that they will become true, because there are so many ways of producing energy. Which are not very good for the environment, but they exist. And so if you are obsessed with this problem of exhaustion, you just open up, the field for nuclear salvation. It was always the trick. It has always been the trick of the nuclear lobby. So I think we have to be very cautious about this idea of energy crisis, which is coming back full force. Whereas, of course, we know that the high price of gas is an accident. It's a for the COVID, for the geopolitics of Russia and so on. There are plenty of good reasons to explain why gas is expensive or oil is expensive. So it's no surprise that Macron is going to announce before Christmas 6 new nuclear plants, because it's a good moment to do that. People are worried about the prices of energy. So yes, I think the discourse about the exhaustion of energy was first a discourse from the nuclear energy, and it is quite a problem that it became a discourse of the environmentalists. It has been a serious failure of the environmentalist movement to enter into this discourse. Because they all, Friend of the Earth and other environmentalist movement, they see the end of oil tomorrow. So they don't talk about oil industry anymore. They don't criticize it anymore, because they think it's a dying field, which is not the case at all, of course.
Yeah, we can ask people, the audience, if you have questions. Yes, we'll try with this because I'm sorry the other mic doesn't work. We will try with this, but if you can also speak.
Can you hear?
Jean-Baptiste, do you hear?
I can hear, yeah.
Okay, perfect.
If transition is not the good word, what are the alternatives?
What are the possible words?
Yeah.
Well, one which is quite obvious is degrowth. Would be first, or I mean, it's kind of obvious answer. Sorry for that. But it's actually degrowth is not necessarily anti-innovation and anti-tech. I mean, you can have innovation and economic degrowth, and it's actually very easy to see that. I mean,
I just wanted to mention an issue that might not be very relevant to the discussion that we had. It's just we cannot hear.
sorry, I didn't understand what you just said. Sorry.
Can you hear me now better?
Slightly better. Try again slowly, please.
Can I hear you? Yeah, just go. I was wondering if you mentioned a discourse that might not be very relevant to the discussion, and it's just seeing, let's say, the history in another part of the world, like seeing it through the global, let's say, South point of view, and see the people that they probably don't have the technology that nowadays we are talking in, talking from in the western part of the world, or like the north part, and they are all already every day bombarded, with the media that this is the technology, this is the new world, and shall be let's say within keeping in mind the degrowth theory, can we also slow down the pace of this part of the book?
I understood just little pieces of what you said. So if it's about the fact that the story I told is really from the rich world perspective, it is entirely true. And basically, I've been through documents of the YASA, OECD, the Federal Energy Administration. So it was clearly, and what is striking is even in the late 1970s, they wouldn't see the enormous growth of China. I mean, they didn't envision that. So they were quite optimistic also for this reason. I mean, they were talking about the rich world. It was rich people talking about the rich world. So of course, it's even trickier if you got a strong economic development in the south. On the
now we are, the debate that we are now facing is not, it's like a global debate. I think it doesn't.
The sound is really, really bad. I'm sorry.
Yeah, I'm sorry. Should be this one. Is it better? Yeah.
No, it is better.
Okay. I mean, I try to speak louder. The debates that now we are facing is, let's say, a very global debate. So, I mean, even though if we are coming to the context from, let's say, a more Western, because probably that's the way that the academy goes. But I mean, the concerns that today we have is also about the countries that are developing every day more and more. And I say, with the situation now, what is the, I mean, if the degrowth is let's say a policy or a strategy that we can follow, is it something that can be somehow with a holistic point of view practical for each and every context?
No, of course not. No, I mean, okay, now I understood the question. Okay, yes, of course. Well, several things. Degrowth is, of course, for rich countries, and the fact that poor countries still have a little bit of carbon credits is quite accepted in most of the IPCC report and scenarios. So, I mean, it's so, I mean, I don't know what to tell. I mean, the other thing is, where there is strong growth of CO2 emissions, it's not necessarily in poor countries. It is in China, in South Asia, which are not poor countries any longer. So, I mean, perhaps it's also, so no, of course, the growth is, first of all, applying to rich countries.
We have another question.